Algebra 1 students, in this video today we will be looking at another type of inequality, and it is called compound inequalities. Okay, so let's jump right into this. Please copy down your heading for today and be sure and include today's date. Alright, your heading is Compound Inequalities, Lesson 6.3, and be sure and include today's date so that your notes are organized. Alright, here we go. Now, listen carefully. Lesson 6.1 and 6.2 were about inequalities. Okay? Remember, they were linear inequalities. Okay? Today, we are still going to study inequalities. Okay? But they're going to be a different type. They are called compound inequalities. Do you understand? Okay? Now, first, understand that we'll be looking at two different types of compound inequalities. Okay? So the other day, lesson 6.1 and 6.2, we studied simple linear inequalities. Got it? Today we're studying compound inequalities. However, there are two types of compound inequalities that we are going to look at today. Please copy those down. One type is called a conjunction, and the other type is called a disjunction. So please make note of that and copy that down in your notes. These are the two different types of compound inequalities we'll be looking at today. Okay? Now, let me take a second and describe these to you. Okay? So I'm just going to write stuff down. I want you to take really good notes. Are you ready? Here we go. Please take good notes. Excuse me. Now, for a conjunction, it will look like this. The x will be in the middle, and you will have two arrows or inequality symbols facing the same way with a number here like maybe, I don't know, -6 and a number here. Okay? That's what a conjunction looks like. I think you're seeing now why it's called a compound inequality. There are two inequality symbols. So we call this a compound inequality. Okay? Now, I'm not asking you to understand this yet. I'm not asking you to get everything I'm saying. Just understand this is what a conjunction looks like. And x will be in the middle. Now, sometimes the arrows can face this way, and that's fine. One of them might have an equal sign underneath it like that, or both of them can have an equal sign. It doesn't matter. You'll have, what does matter is that you'll have an x in the middle, and the two arrows will be facing the same direction, to the left or to the right. You'll have a number over here like, I don't know, 12, and a number over here like -13, or what it doesn't have to be a positive and a negative, so we'll say a 12 and a 6. Okay? That is called a conjunction. Now, here's what the graph looks like when you graph a conjunction on a number line. You'll have a point here, we'll say at -1, and a point here at like at 5, let's say. Okay? Please copy this down. When you graph a conjunction, it will always come together like this. Just like that. So when you graph a conjunction, it's going to be a region like this, bound between two numbers. One of the points might be closed. They both might be closed. Or they both might be open. Okay, it doesn't matter. But a conjunction will look like this. It'll be a set region, a set of numbers bounded or bound by two numbers on the outside. Okay? And by the way, it's associated with the word and. I would write that down because a disjunction is associated with the word or, and we'll talk about that in a second. Okay? Now, why do I say and? Well, I'm glad you asked that question. Did you write this down like I asked you to? Here's the conjunction for that. Write this conjunction down, please, if you would. Now, we'll talk about this later. For right now, just write this down, please, okay? Everybody write this down, please. Everybody write this down. Now, notice I have a -1 here, -1 here, a 5 here, a 5 here, and my shaded area right here. Now, the reason we say that a conjunction associates with the word and is because you would say x is greater than -1. Right here it is. You would say x is greater than -1, and it's also less than 5. It's both of those things. So when it's both, we use the word and. If I want you to go to the store and to the gas station, I would say go to the store and go to the gas station. If I wanted you to do both of those things, I would use the word and, correct? If I wanted you to do one of those things, I would use the word or. I would say go to the store or go to the gas station. That makes sense, doesn't it? If I want you to do both things, I use the word and. If I want you to do one thing, I use the word or. That makes sense. So a conjunction has two things that must be satisfied. The x has to be greater than -1, and it has to be less than -5. Both of those things. So we use the word and when we read this. We say x is greater than -1 and less than or equal to 5. So that's a little bit of an introduction to conjunctions. Now, let's talk about disjunctions, okay? Here we go. Please take some really good notes on disjunctions. First of all, here's what a disjunction looks like. Please write this down. A disjunction is two different inequalities. That's why it's compound with the word or written in between them. Okay? That's what a disjunction looks like, so please make note of that. The graph would look like this. Think about it, guys. Here's 0. Here's -3. Here's 8. Read this out loud. X is less than -3. So it goes this way, or you could do it like this if you wanted to, however you want to do it. X is greater than 8, so it goes this way, or like this. Do you see the difference? They're going in two different directions. Listen to me. In a disjunction, you don't have an and situation. You don't have both of these things. It's impossible to say a number is less than 3 and it's greater than 8. That's impossible. It's one or the other. Either a number is less than -3 or it's greater than 8. It can't be both. So a conjunction deals with the word and, in which you have two situations that both of them must be satisfied. A disjunction involves a situation with the word or, where you have one situation or the other situation being satisfied. Now that's what you need to know about conjunctions and disjunctions. Now, let's jump into solving these and graphing these. We're going to do 4 of these. 1, 2, 3, 4, and then we're going to look at a couple of some sentences here I want to convert over and we'll be finished. Okay, it's not very long. Okay, let's solve this conjunction. Now, you should notice right away it's a conjunction. I have arrows and x in the middle. I want to solve this. I'm not going to give you guys steps. It's pretty simple to do. Your goal is to obviously get x by itself, right? I mean, if I'm solving an inequality, I want to get x by itself. So, what two numbers do I want to get rid of? If I want to get x by itself in the middle, I've got to get rid of 3 and -8. Well, like always, save the coefficient for last. So our -8 gets moved here. But it also gets moved here. You have to move it both directions, okay? -2, +8, 6. 10 and 8, 18. Now I want to get rid of this 3, so I divide by 3. But you must divide every part by 3. 6 divided by 3. 3 divided by 3. 18 divided by 3. And we're finished. Mr. Airwright, how do you know that you're finished? Because x is all by itself in the middle. You're done. Now how would you read that? You would say x is greater than 2 and less than or equal to 6. How would you graph it? Well, I'm glad you asked that question. Obviously my critical values are 2 and 6. equal sign here. Now remember I taught you this the other day in lesson 6.1 and 6.2. Always read the inequality from the x. You don't say 2 is less than x. You say x is greater than 2. So we're going this way. And x is less than 6. So we're going this way. Or if you want to do your graph like this, that is fine also. Either way is fine. I'm not trying to rush, but they're just not difficult. Let's try another one. Okay, here we go. This is a conjunction. Let's get x all by itself. Are you ready? We have a negative 2 to get rid of and a negative 1 right here, even though you can't see it. We have a negative 1 to get rid of. Let's first bring the negative 2 over here and make it positive. Bring the negative 2 over here and make it positive. So we're left with a 0, and then a negative x, and then a 4. Got it? Now what's in front of the x? A negative what? 1. So we're going to divide everything by a negative 1. 0 divided by negative 1 is 0. Here your negative 1's cancel, leaving you with x. 4 divided by negative 1 is negative 4. Now hold everything. What kind of number did you divide by? A positive or a negative? Negative. So what did you learn the other day? You have to turn the arrows. So this arrow now faces this way. This arrow now faces this way. And there's your answer. You must turn both arrows when you're dealing with a conjunction. When you divide by a negative number, you must turn both arrows. Alright? Okay, let's graph this. My critical values are 0 and negative 4. Both points are open because there's no equal sign under the arrows. X is less than 0. X is greater than negative 4. So there's your graph. If you don't like that, you can also do it this way if you want to. I have no problem with that. Now let's get into solving disjunctions. They are just as easy, maybe even easier. In a conjunction, my goodness, you're just simply taking this inequality, solving it, taking this inequality, solving it, and then when you're all done solving it, bring down the word or and you're finished. It's really simple. So let's solve this one first. Bring the 1 over and make it a negative 1. And you're left with 3x is less than 3. Now divide both sides by 3 and you're left with x is less than 1. Now on to this one over here. Bring the 5 over and make it a positive. Do you see what I'm doing? I work out each one of these like they're a separate problem, even though they're not. That's how I solve it. So I'm left with 2x is greater than 12. Now divide both sides by 2, and x is greater than 6. The only thing left to do is to pick up your or, bring it down here, put it right here, and you are finished. And you would read that by saying x is less than 1 or x is greater than 6. If I asked you to graph it, your critical values would be 1 and 6. Both of those are open. There's no equal signs here, so we're not going to shade them in. X is less than 1, going this direction. X is greater than 6, going this direction. If you want to use the other form of graphing where you kind of go like this and put an arrow, I have no problem with that. There we go. Notice it is an or situation. It's either less than 1 or it's greater than 6. Okay, here we go. Let's solve another one. This is a disjunction. You should recognize that right away because we have an or right here in the middle. A conjunction has your x right in the middle like this with two inequality symbols. Okay? So here we go. Let's solve this one first. Negative 2x plus 3 equals negative 1. So let's go ahead and bring our 3 over. In fact, we ought to see if we can do this. If it works, I'll have to wait a second. And maybe it's not going to. There we go. So we'll just cover up this part over here like that. There we go. Alright, so we're going to bring our positive 3 over and make it a negative 3. And we're left with negative 2x is less than negative 4. Okay? Now divide both sides by a negative 2. and you're left with x's. Notice you divided by a negative number, so turn the arrow. X is greater than 2 because negative divided by a negative is positive, positive 2. Alright, now let's work on the other side. Okay, here we go. Bring the negative 5 over and make it a positive 5. And you're left with negative 3x is greater than or equal to 3. Okay, divide both sides by a negative 3. These cancel, you're left with x. Be sure and turn the arrow because you're divided by a negative number. Positive divided by a negative is negative 3 divided by 3 is 1. Then all you have to do is simply put the word or right here, and you have your answer. X is greater than 2 or it's less than negative 1. If I asked you to graph it, you've got a 2 here, negative 1 here. Negative 1 is a closed point right here. Positive 2 is an open point. X is less than negative 1. X is greater than positive 2. Pretty simple, alright? And of course you can do this if you want to instead. Alright, now, so that's how you solve and graph conjunctions and disjunctions. Now we've looked at solving these. Now let's look at using words to write compound inequalities. I'm not going to give you a lot of examples. These are pretty simple, but we still need to make sure that you know how to solve these types of problems. So here we go. X is less than 5 and greater than negative 2. This and right here is the key. That means you're dealing with a conjunction. Got it? So I've got an X. Now, the smaller number, well, I think the best thing to do is to get a picture of it. We know we're dealing with a conjunction. I'm telling you guys, I'm not going to make you graph these. It's up to you, but I'm telling you a graph will help you write the inequality. My critical values are 2 and 5. X is less than 5 and greater than 2. So there's the graph. And I can see there's no equal sign. It doesn't say x is less than or equal to 5, greater than or equal to 2. It doesn't say equal anywhere. So these points are open. Now once you get a picture of it, my goodness, watch how easy it is to write the conjunction of this thing. Put your x in the middle, bring down the number to the left, bring down the number to the right, have your arrows drawn to the left, and you're finished. Would you put equal signs here? No, you would not, because both points are open. If one of them was closed, then you would put an equal sign here. Alright, so drawing a picture will help you write the conjunction very, very much. Let's try another one. X is greater than 3 or less than negative 1. Now I see an or, so I'm pretty sure it's going to be a disjunction. But let's graph it and make sure, okay? My critical values are negative 1 and positive 3, okay? X is greater than 3, so I know there's no equal sign there, so I leave it open. Or less than negative 1, leave that an open point. So yes, look at the graph. Do I not have a conjunction? Sure I do. So right here in the middle I put what? Or. For this I write what? X is less than negative 1. For this I write x is greater than 3. And that's it. They're really not that difficult, and that's why I'm not going to spend a lot of time on them. Okay? Go back and watch this again if you need to. Make sure you understand how to write these. Now lastly, I want to go backwards and make sure you guys know how to write these expressions with words. Okay, that's very important. So let's go to our very first problem that we solved right here. Okay? Go back in your notes to this problem here, would you please? Thank you. Go back to your notes where this problem here is and look at your answer. Here's your answer. See it? What if I asked you to write that with words? You would say x is greater. X is greater than 2. And then you put the word and, it's a conjunction. And less than or equal to. Less than or equal to 6. Now here's the thing. I know you guys see the word or here. But understand that or is less than or equal to. It's not actually I should have put the word 1 here to be technically correct. X is less than 1 or greater than 6. And that's it, guys. Okay? Not difficult. Very simple math. Again, we're dealing with compound inequalities. Hope this video has made sense to you guys. We've looked today at conjunctions and disjunctions.